Le Chatelier's principle is when any factor affecting equilibrium is changed, the system will shift to minimize that change. So the reaction itself will either go from reactants to products or products to reactants to reestablish that equilibrium. Now, why does the shift occur in the first place is because there's some sort of stress put on the reaction. So either the scientist has added a certain chemical or it has somehow taken a chemical away, added pressure, added temperature, or things like that. So first thing we're going to talk about is concentration. So the concentration is how much of something per a certain amount of volume. So an increase in concentration, now remember you, the scientist, is increasing the concentration. So you're adding something in. So when you add something in, the reaction itself will then shift the opposite direction of the addition because it wants to reestablish that equilibrium. So for example, if you have A plus B produces C, and you, the scientist, adds more A in, it has to rebalance itself, so it's going to shift to the right to produce more C to become equal again. So for example here, I'm going to show you with a scale. So if you start off with equilibrium, and you have one reactant and one product, they're equal, okay? You, the scientist, adds more reactant. So I'm going to add some more reactant. When I do that, that causes the reaction to become out of equilibrium. So it has to fix itself. That's what Le Chatelier says, is it will actually fix itself and go back to equilibrium. So when that happens, this has 3 here, only one product there, so what ends up happening is that the reactants will shift towards the products. So then therefore it goes back to being equilibrium. Okay, now let's say I added more product. So I add more product. Okay, I, the scientist, did that. So then what you have to tell me is what will the reaction now do to fix itself. So when I added the product, that makes it tilt towards the product side because there's too much product. So what will the reaction do now to put itself back in equilibrium? Well, we need to get rid of some of the product because we added that, so now it's going to shift to the left to produce more of the reactants. So product turns into reactant. When that happens, everything goes back to being equilibrium. Okay? Now, let's say we decrease concentration somehow. Okay? So somehow the scientist is going in and taking something away. So this time it's going to shift in the same direction of the subtraction because it has to replace what you just took away. So, for example, if I take away some reactant, I take some of the reactant away, that puts you more products. So now the reaction itself is going to replace what you just took away. So in that case, some of this product needs to shift into a reactant, and it becomes equal again. Okay? So going back to that, remember, an increase in concentration, the shift will always go in the opposite direction of the addition because it has to get rid of what you just added. A decrease in concentration, it has to replace that, so the shift is going to go in the same direction of the subtraction. Now, this is the most important thing right here to understand in order to do Le Chatelier's principle. You have to know what a shift means. A shift means the reaction will go in that direction and will cause the following. So the reaction itself will go in that direction to cause the following. So the concentrations will increase in the direction of the shift. So if the reaction shifts towards the right, that means everything on the right side of the arrow is going to increase. Then whatever direction you're going, the other side will decrease. So for example here, on the example I have, if this reaction shifts to the right, that means the concentration of C will increase and the concentration of A and B will decrease. Okay? So that's concentration. Now, let's talk about pressure. Pressure, you pretty much need to understand the gas laws that we did in Unit 7. So remember that if you increase pressure, you decrease volume. So that gas has to go somewhere. So the key thing here is increase in pressure. You've got to remember decrease in volume. So it's going to shift to the side with the least amount of gas. Okay? So the example here, you have N2 plus 3H2 produces NH3. Okay? So let's say I increase pressure. Which side will the shift go towards? So you've got to remember, if you increase pressure, that decreases volume, so you have to have the least amount of gas in there to make up for the pressure that you included here. So which side has the least amount of gas? This side or this side? So how do you know? You're going to look at your coefficients. So on this side you have 1 plus 3, which is 4. So you have 4 molecules of gas on this side and 2 molecules of gas on this side. So least amount of gas is over here. So that means you would shift to the right. Okay? For this example only. You cannot memorize an increase in pressure always goes to the right. Okay? You have to remember that it's going to the side with the least amount of gas. So in this case, it is to the right. Okay? Because of that having the least amount. Now let's say you decrease pressure. So you have to remember decrease in pressure means you have an increase in volume, which means you have a lot of space for these gases to go. So you're going to go to the side with the most gas. So this time, you look at your coefficients. The left has the most, so you're going to shift to the left on this example. Okay? Lastly, temperature. Temperature is a little bit tricky. You just have to remember a couple things about it. So you always need to figure out where energy or heat is in the reaction. So this is the example I've given you. A plus B produces C plus energy. Okay, it's always important to figure out where this is in the reaction. So increasing temperature means you've added heat to it. So that heat has to go somewhere. Okay, so the reaction is going to take control of the situation, and since the heat has to go somewhere, it's actually going to absorb it. So since it absorbs it, it's always going to shift away from the energy. Because remember, in endothermic, because this is endothermic, the energy is always a reactant. So you shift away from the energy. So in the case of our example here, it's going to shift to the left because it's absorbing that energy. Now if you decrease temperature, the reaction is going to warm up the surroundings to take control of what you've done. So when you decrease temperature, it's always going to shift towards the energy because it's going to become exothermic. Okay? So increase in temperature, you shift away from the energy. Decrease in temperature, you shift towards the energy. Those are the key things there for energy, for temperature. Now, going back to the first video with equilibrium, you have this K value. Now, if you realize in all the other ones, concentration and pressure, I didn't mention anything about the K changing. That's because K does not change with concentration and pressure. It only changes with temperature. And the thing about this is you pretty much need to remember that K does the same thing as the products. Because if you remember, K is your products over your reactants. So if the number on top increases, that means K is going to increase. If the number on the top decreases, that means K decreases. So K does the same as the products. Okay? Now in class we will go over some more examples. Just make sure that you go back through the notes and you write down the key elements to doing Le Chatelier's principle.
Le Chatelier's principle says that if you induce a stress on a system at equilibrium, the equilibrium will shift so as to relieve that stress. So let's see some examples of a stress we could put on a system at equilibrium. First, we could modify the concentration of any of the compounds. Let's say we add some of this reactant. That will unbalance the equilibrium, and the forward reaction will speed up to use up some of the additional reactants, turn them into products, and restore equilibrium. The equilibrium is said to have shifted right. If we add more products, it would shift left. Likewise, if we selectively remove one of the components, the equilibrium will shift to produce more of that species to restore balance. That is one type of stress we could put on a system. Another stress would be to change the temperature. To see how this would affect an equilibrium, we have to see whether a given reaction is exothermic or endothermic. This tells us whether a reaction absorbs or releases energy and is signified by delta H, the change in enthalpy. If delta H is negative, the reaction is exothermic and releases energy. So we could think of heat energy as a product of this reaction. If instead it's positive, that means it's endothermic, and energy must be absorbed for the reaction to go. So we could think of heat energy as a reactant in that scenario. Once we translate thermochemical data in this way, we can treat the word heat as just another substance involved in the reaction. Higher temperature means more heat, so things will shift to the other side to use up some excess heat and relieve the stress. Cooling it down would have the opposite effect. The third stress we can examine is changing the volume or pressure. Let's say the equilibrium involves gases in a balloon. What if we decrease the volume? If we remember Boyle's law, we know that the pressure will go up, since the smaller the volume, the more the particles will hit the sides and exert pressure. If there is a discrepancy in the number of moles of particles on either side of the equilibrium, it will shift towards the side with fewer particles so as to alleviate some of the additional pressure. In this equilibrium between a diatomic molecule and two monoatomic species, the right side has twice as many particles. So shifting left means atoms fusing together, resulting in fewer particles, which lowers the pressure on the container. If we increase the volume, thereby lowering the pressure, the equilibrium would shift towards the side with more particles in order to regain some of the lost pressure.